Okay, good morning. Question number one, when do we usually start, or to backtrack, when did you usually start here with Marius?
We're supposed to start 15 over.
Good, okay, good. I just want to check that. So, because I, just checking because the room is surprisingly, or not surprisingly empty, put it this way. So I just want to be safe that I'm not doing anything without, you know, waiting for the proper arrival of the majority. Are you guys also in favor of early starts, or are you a bit more on the late side?
I wake up in roughly 5 minutes, so I'm ready.
No, I mean as in 8 o'clock starts. Are they good for you or not good for you? Not good for you? Are there some people which is really good? Who say, yeah, sure, whatever?
Preferably as early as possible.
Preferably? Okay, for who, how many of you it doesn't matter at all? Okay, and then there's another bunch that says, nah, not happening, right? So that's the usual distribution. I check that frequently. It's usually 1/3. 1/3 says, yeah, let's do it. The next says, yeah, whatevs, as long as they get it done.
The people who don't like it aren't here, I think.
I think, and so that would substantiate the point. Well, plus the few ones, there's probably around 40% then of the class that doesn't really like it. So it's another good argument for thinking about the schedule. But anyway, beyond the point. So what's the point today?
I think I'm seeing a postman.
Sorry?
I think I'm seeing postman.
Yeah, we get there, one after the other. So what does it tell you, most likely?
Probably you're going to test some REST API or something like that?
That's possibly happening. We'll see how time permits, but we're not quite there yet. So that's just my prep, you know. I need to set up my props, and then we'll see where we end up. So with respect to Linux, we're kind of nearly done, but there's still a few things I want to mention, because I think it's too important to omit that, because we talked about permissions in Linux, we talked about creating users. Those were some of the more important aspects. How the prompt looks like, how you switch into super user, for example, the hierarchical file system, how it looks like in Linux, unlike in Windows, for example. Of course, you don't really need to use that in practice right now, but it's important for you to understand it, because eventually you will log into OpenStack or AWS and you find some virtual machine. You need to be able to configure it and have some baseline understanding. Most likely it will be an Ubuntu installation, so you should be fairly comfortable with that operating system at that stage. Of course, you know, if you don't, if you have gaps or missing things, there's always opportunities to look it up. But I want to leave you with some commands, so you have a basic vocab handy when you need it. And one of the aspects we didn't talk about is processes. In Windows, how do you manage processes? So not at all, or what? Okay, yeah.
Task Manager?
Task Manager is the dominant tool, right? Is that the only tool of doing that?
You can do it from the command line, but it's fiddly.
Yeah. But which command do you use on the command line?
I don't remember.
Okay, yeah, fair. Yeah, that's all sensible. I think there's even the equivalent implementation for kill in Windows in the meantime.
Yes.
But the syntax is slightly different, so that's kind of defeats the point. But again, processes are important, and unlike in Windows where you have usually UI, I mean there are server installations that don't have a UI in Windows, then it becomes a bit more challenging, but most of the time you have UI handy, and that makes it very easy for you to you know, press Control-Alt-Delete, and then you get your option to start your task manager. In Linux you need to be a bit more explicit about it, and there are a few commands that you should have on top of your head, and they're pretty much in any Linux installation. And one of them, the more prominent one, is top. And that does pretty much exactly what you expect from a task manager. It runs persistently in the foreground, and it shows you a lot of information about your system, including your CPU use. So right now CPU is pretty much idling, the memory use and the swap memory use as well, even though that's like the virtual memory that's used by the system. I'm not going into that one right now, but this is basically you know, typical aspects you see there, and most likely then you'll see different processes, you know, and the UI updates I think once a second or something like this, and shows you the highest, the most important processes. So when you do that, one of the aspects is the processes that you see, and you see it's quite a lot of them, and most of them are irrelevant for you because they're system related, and sometimes a bit hard to figure out which ones are related to you. In this case, I was running as the root, no, I was running as user, in fact, that's right. So if I go back into top and you want to actually constrain and only show the processes that user actually runs, you can press U. So top is full of single letter commands that allow you to select basically the user. So if you press blank, you get all users, but most likely you get a lot of system processes, so they're not particularly useful. Constraining to user is much more sensible, because then you see actually stuff that you are running. And most importantly, one of them is bash. What is bash here? Please. If I come back to you in a second if there was something. Bash?
It's
yeah?
shell.
Exactly, it's the very console that we're running, right? So it again shows that it's kind of a nested approach. So we're running bash on top of bash, we're running top, right? So those are the two processes you're running, plus a bit of background stuff for authentication. Was there a concern? Oh, right. No, I can't. You will need to. So it's a gentle, I would say, 1.5 second press on the right side of the back, and usually they come on eventually when they start blinking here. Does anyone willing to emulate this on this one? Just go for it. You can't break much. They usually check it, yep. So yeah, and then once they blink, then they're okay. So in case that happens, you guys know what's going on. Thanks for the reminder though, that's very helpful. So because you guys should have a glimpse as well. It should come off in a second. Good. It's blinking, right? Yeah, it's coming. Good. All right. So that's pretty much top. So you can constrain and you can do a lot of different things. So if interactive commands, I just put H for help. And you see what you can do. You can colorize things. You can, most importantly, where do we have it? Filter by particular users and set the update interval and so on. So you just press the help command and try out stuff. But I just want to show you that command because it's too important not to know it. If you want to leave top, because it's a kind of interactive tool and persistently running in the foreground, use Q. So, any more comments on that for now?
Could I recommend testing whether htop is working, is installed?
It's not installed by default. Oh, it is. Hang on, it may not be because that's a prep machine already. Often it's not installed. So this is the, you introduce it.
It's actually top, but with more powerful user interface and more powerful commands. That's basically it.
That's right. It's an advanced version. The reason why I'm not directly jumping to htop is that it's oftentimes not available. You need to install in the first place. So that's why I'm a bit reluctant. But if you know top, and then yes, htop is a very good point here. So the options here are fine. And in top, you have the same one, of course, in htop and many more. Filtering, searching is richer, and so.
You have the nice information on the bottom showing how to quit and do other stuff.
It's a bit more context. Nice is very relative, but yeah, of course, sure. Let's call it nice. Whatever. So, but yeah, htop is pretty good. Yeah. So what both those tools, top and htop, have in common is that they're interactive, right? So you basically they are running in the foreground. You can interact with them and so on. If you're running from the command, want to run something from the command line and just get some output, especially if you want to parse it or use it in scripts or the like, you need to have other tools at hand. And one of them is PS, of course, which is the standard tool, again, available on any Unix machine. So that implies any Linux machine. And it basically just by default shows you your processes you're running. And again, it has a lot of powerful options, showing all processes, showing all, UX, showing all processes on the entire system. So basically, you have roughly the same output you get from top, but it's like a snapshot basically, and then you can, for example, parse and process it, and so on. So slightly, of course, simpler in its execution, but this is for scripting. Top and htop more for interacting with it. So why do we need this whole process thing anyway?
If some command is executing, or you're actually suspecting that the program is hanging.
Yeah.
You would like to kill it.
Exactly. So yeah, exactly. That's a standard case. So here the example is what I did just now. what I did just now was running top in the foreground, like that. So, and then was sending the signal control Z, and that stops the process, but it doesn't really remove it from memory, so it still sits there. And that can happen for arbitrary reasons, of course, right? Most likely, some bug, some uncaught exception, for example, or a defective daemon. We later on start deal with a lot of system-level tools that may have issues at time. For example, Docker, right? So the daemon can be hanging. We need to find a way of getting rid of it because it occupies your port number that you want to expose the service on. And unless you get rid of that, daemon background service in Linux, in Unix terms, Unix lingo, then you can't really, host another service on port, let's say 443 or for port 80 or the standard ports you would expect for any internet service. So that's why we briefly go about this. And so the if you press PS, now we have two top instances, and they're kind of both stopped, right? They're no longer really active, but you want to get rid of them. And the key important piece of information that you need to have is basically the process number, right? The process ID rather. So it's yet another ID that Linux or Unix has, apart from user ID, inodes, group IDs, and so on, is also the process ID. And why do we operate on process ID and not process name? There's an intuitive example here. Please.
Because you have several tops and they have unique IDs, not unique.
Exactly, right? You could write your own application, name it top on top of it. So it's not particularly helpful if you discriminate based on ambiguous information. So now we need the process information. The idea is then to run the kill command, again, available on all standard Linux systems, and see what it does. Surprise, surprise, nothing. Yeah, okay. So the kill command comes in various flavors. So I have a mini slide here just to bring it up. And if we interact, what happens here basically, kill is not necessarily a kill command, it just sends signals to processes, right? So you can inform the processes of, okay, what they're supposed to do. A process has an inner execution, right? So it has it executes compiled code or whatever else, but this is just contained within a process container if you think about it. But from an operating system point of view, the process has a name, it has a status, it has memory allocated and so on, but it doesn't really know much about the internals. It can just say, run that process, suspend the process, stop the process, and so on. And the means of interacting with this process from an operating system level is done by signals. And one program to send actually signals to processes is the command kill. And it's named kill because it's most likely used for that very purpose, just to kill a process. So if you want to see all the signals that are available, it's quite a lot of them. Not all have practical, really practical use nowadays. But the most common ones that by default send is the signal 15. If I find it, yes, there you go. Sig term. So it sends the signal for terminating. The mouse doesn't run in that box here right now. For terminating a particular process. But this requires, so the termination signal requires the process to actually be actively listening and responding to that request and saying, yeah, okay, I got the signal to terminate myself, let's do it. But the process can overrun this. It's not a mandatory, it doesn't necessarily need to honor that particular request. But sometimes you need to really kill something and get rid of it entirely. And the only way of doing that is use a different, stronger signal, which would be sig kill in this particular example, right? So here's a bit of a list. Those are probably more relevant ones. The sig term is the standard one. Terminate the process in an orderly way. Sig int, so that would be signal number 2 in this example here. Again, kill-l lists all the signals that are available. It would interrupt the process, but again, it can be ignored. And sig kill, or signal number 9, interrupts the process. The process cannot ignore that signal, meaning it's really removed from the system. So various other ones, for example, this one here, for signal, I think it's called hang up, and the idea is there that daemons continue running, but reread the configuration file and continue running. But okay, let's do the kill 9, just for demo purposes, so we get a feel of what's happening. What is it, 4636? And now it's explicitly said I killed top here right now, right? So that's your hard way of getting actually rid of processes. So in case you run into that issue during development or deployment or doing submission of your assignment in particular, because I suspect that issues may happen during that time frame, that command may be able to help you. There are some other forms like kill all. Kill all is a bit richer in a sense that you can just kill programs by name. If you know you have only one instance of top running and you just want to get rid of it without bothering with the process ID, you can just use kill all and then the process name associated with it. So it will kill all instances, but in this case we of course don't have any of them. Cool. No magic there, right? Easy. Yeah, it's just mechanics, just infrastructure. No, yeah. So we leave it that. So that's not too fancy. Just bear that in mind when you're actually developing, because that's more like a practical problem you have. Of course, not a realistic challenge theoretically. Of course, you may encounter some of those aspects. I don't know. We'll see in how far in the operating system course. I think you cover some of those aspects. So the other aspect that we didn't talk about is installing software, right? So who is competent and comfortable installing software on Linux generally? Of course. So yeah, of course. Hang on. Who? Okay, so that's bit. So let's briefly run through of what actually needs to be done conventionally if you run installation on Linux systems. Of course, this is like super compressed, and it's a kind of geared towards Ubuntu systems in particular with respect to installation, just to make it quick and easy for you, and foremostly to understand the commands you have been using during the Go setup already, or may not have been using, but you will certainly use them at some other stage. All right. Originally, if you run installation on the Unix system, it's kind of a bit more tedious compared to Windows system, and this is part, at least that's presumably part of the reason why Unix had such a hard time being adopted by a broad set of users, because it's not only hard to install stuff, it's even harder to uninstall stuff. So because there's no structured installer routine like in Windows, so basically everything comes with its own installer and knows where stuff is put and it's registered, and then you can uninstall it from the system programs and features control panel point. So it's quite straightforward. Whereas in Linux, the idea is, or Unix, is that you install a service and you run it for considerable time. And that was quite true in the 1970s and so on. If you set up a bind server, which is the DNS server implementation that was commonly used on the internet, not sure how the use is nowadays, then you basically did the following step. You downloaded some sources, right, which are ideally in C, which is natively understood in Unix systems, as a tarball, so the famous tar.gz format. So you decompress those ones, and then they always contain a script that is called configure. And this is software specific, so usually has the variation of help that allows you to inspect, okay, what are the, okay, well, use the other monitors. What are the, it will come back in a second, at least, I hope so. What are the options I can set for a particular software package, right? If you, for example, have a web service, you can set up, does it have SSL encryption, or where specific libraries lie on your machine, and so on. So it's very software specific, but the rule of thumb is there's a configure script. Once that is done, you basically prepares for the actual compilation of that software of choice. So basically after that you just blindly run make, right? So it will use the configuration options that you provided and produce a make file afterwards. And finally you will run make install, and that's where the actual installation only happens, right? So raw sources configuring, system specific preparation, compilation and installation. Yep, and that was pretty much it. So, and then it's pretty tedious to get rid of afterwards because nobody bothered dealing with this because there's no conventional, de and uninstalled script or the like. Of course, there are workarounds, but let's not be bothered with this one. So, compilation is fairly generic. It made it super easy to distribute software because you have your tarball library somewhere, and then the administrator needed to deal with customizing it to his or her own system. Which, surprise, surprise, didn't really work that often unless you really needed the program. So you're not likely to try out something and discard it afterwards. You're very sure you're going to run this Apache server or this database management system or whatever else for a considerable amount of time before before you invest that effort in doing it, right? Any observations as an admin?
There is another caveat when installing from source, and that's actually dependent libraries.
We get, yes. You're always one slide ahead of mine, so that's good. So exactly the point. So, so this is of course a challenge. Not only the configuration, but distribution of updates, of course. And there we are, dependent libraries, and that is quite tedious in a way. So we briefly have a skim of how one could deal with this. And the idea was there. That was by the founder of. So that was Unix times basically, and. In I think 1993, so quite some time ago, Ian Murdoch, I think was his name. He was the founder of the Debian Linux distribution. Sorry, Debian Linux, and he was bothering with thinking about, okay, now we have this Linux which runs on a 8386. Wow, really, on a home machine, home computer, but people still have the same problem. They need to do the manual compilation. And he said, well, we need to find a more standardized way of dealing with this. And he came up with the advanced packaging tool, right? Also called apt. And some of you have seen that or used it on the command line. That's the thing. All right, what does that thing do? The idea is basically that it encodes comprehensively all the requirements or prerequisites or dependencies that a particular software has. Provides the sources of the software itself. For example, if you were to install Apache using apt, so the advanced packaging tool, it would check, do you have the SSL libraries, do you have the necessary networking libraries on the system already before actually installing the Apache compiled files, the Apache binaries themselves, and register them as services. So it can never happen that you have a service running that depends on something else and without having those dependencies installed. That's the key idea. So you kind of have a web of dependencies that the system basically manages. And every time you install something, it will suggest you 5 million other things it should install as well, because those are the things, the particular binaries that you want to install depend on. And that was incredibly successful. Yeah, this was kind of incredibly successful and has been copied or adapted in different ways by many other distributions, of course. Most famously, Red Hat with their RPM package and the associated manager Yum. Is it still current, or did they change that? I'm not sure. Sometimes they various distributions change their package manager over time. For Debian style distributions is Deb, .deb package. So if you go on the homepage, some website, sorry, and you find there's a .deb package that is most likely geared, or is geared for Debian installation. So you should be able to install it on the machine you're interested in. And then there are other ones like for Slackware, which had its own format, and for Arch Linux, which relied on the package format and so on, and using pacman as an install tool. So the idea is distributions have stratified themselves by different characteristics. That was currency, meaning Red Hat, or particular Fedora, was always kind of ahead of the game, has the latest technology. Debian was always geared towards very stable server-side execution and insisted on free software as part of its, everything it provided. Whereas Ubuntu is more like a desktop-facing modern variant of Debian, a bit more current, and so on. So then there's the hardcore distribution Slackware, one of the oldest ones, and Arch Linux, which is so-called rolling distribution, where there's no really versioning. So the idea is that you continuously update the operating system. So there's no distinct differences between versions, but it's just updating all the core components continuously. A rolling distribution, which can be painful from an admin perspective, but very convenient from a user perspective, of course. So, if you buy into a particular packaging format, you're also buying into different distributions. So it's something to be aware of as well. So the main thing is really, as mentioned here, is the resolution of dependencies. And that's one of the main aspects of it. But I'll put this thought to the side for a second. But I also want to highlight, apart from the packaging format, how do those actually work? And it's a bit like what you know already from your mobile phones. But we need to think back 1993. So it was fairly revolutionary, if you like. And the idea is as follows. How do we distribute software? Do we go down the Windows route and say, you know, we download a software package, click on the MSI executable, and hopefully an installer comes up and it will not say your system is not compatible to that installation? Or do we have another more centralized way? And that was the approach taken in Debian in particular. So the idea was there, okay, our packages that are running on a Debian system should be available in a pre-compiled version somewhere on the internet. And ideally only once anyway, right? So you're not going to a homepage and download the .deb package. You can, of course, but you shouldn't. But in some sort of catalog, right, that lists all the different packages and has links to them, usually from the distributor side, meaning from Canonical, which is the maker of Ubuntu. Yeah, so basically downloading those packages. And that's all the same for all the package manager and fundamentally. So this schema applies to Debian as well as RPM and so on. So, and instead downloading all those packages, which, because it's just plain stupid, because there's a lot of them, the idea is there that the distributors provide some sort of catalog. Hang on, is aptitude on this one here? Yeah, it is. So, provide a catalog of available packages, as you see here. So here it tells me already, okay, there's a lot of stuff that is actually upgradable, and the packages are organized or categorized by different categories, which apparently made sense at that time. I'm not sure if it's super convincing nowadays. But admin, development, kernel, and so on. So it's different for different purposes. It could be just various system utilities. It could be the desktop system of your system and related packages, and so on. And but if you look at the number, so 4,702 packages are available, and of course that's not the kind of stuff you want to store on your hard drive and only install if you actually need it, right? So the idea is here, no, we only keep this catalog handy, and then download packages whenever we actually need them, right? So, and you could do that using visual tools such as this one here, where you can individually walk through the entire configuration and select packages. Oh, there's another 82,000 are the non-installed packages, so that's a bit more interesting number, I guess. And there's a lot of stuff you never heard of and hopefully never need to hear of. Yeah, so it's pretty much everything in there. You find, for example, Java in there, Go in there, Node.js is in there, and so on. So that's pretty good. Could make life a lot easier, mostly. But what we need to do for that purpose is, of course, to update this catalog, because it only holds a local copy of the catalog, but of course things change over time. And therefore you need certain commands to actually ensure that you have the rights. So that's your package manager, and there's a certain repository, and you need to keep this catalog current. How do you actually do it? What's the command to do it?
Apt-update.
I didn't hear that, sorry.
Apt-update.
Cool. Yes, apt-update. So, yeah. So this says, okay, something is locked, you can't do stuff. That means I didn't run sudo because it's a system-wide command, right? It influences, it changes the system configuration potentially. Therefore, it insists to do it as super user because it affects other users as well. Again, remember Linux is a multi-user system, so we need to be considerate of others, even though it's not necessarily realistically the case. And why don't I know my own password? 3 incorrect attempts. Damn, not good.
Luckily you can do it again.
Lucky I can do it again. I mean, it's super simple. Ah, there you go. That is simple. All right, cool. So what it does basically is just updating this catalog for all those different, branches of things. So it picks out the relevant operating system services and then packages that apply to my machine. And it takes a bit, but it's only downloading like 3 megabytes. Basically just a list of packages, and it tells me afterwards, oh wow, 102 packages can be upgraded, so your system is slightly behind. Right? But the point is here, it's one command away, and you know what's happening on your system to some extent. And of course, then you can actually perform the actual upgrade. That is then what is the
Upgrade.
Upgrade, right? So that's the yeah.
You do have a variant of it.
Yep.
But the dist upgrade will also will upgrade packages that won't be upgraded with upgrade.
Yeah, that's right.
There are 2 versions, but I'm not sure why there are 2.
Traditionally, the idea was that you can take a leap of faith and do upgrade your distribution at the same time, core elements of the distribution. This will only be, irrelevant packages that don't have really a strong system relevance. Nothing else really relies on it. So that's the safe way. Dist upgrade, in my experience, is the unsafe way. Like the really unsafe way, because there's very limited support. I wouldn't necessarily recommend it. I generally go down the route saying, yeah, you know, you'd rather reinstall your entire Linux and then run a proper upgrade, you know, latest state, instead of updating.
My VM host at home,
yeah.
Dist upgrade is the only supported option, actually.
Only supported option, okay.
Cosmos, yes.
Okay, but if it's supported, then you're good. So, I mean, you know, so but officially supported. It really depends what kind of software configuration you're running on your machine, and it may just work, especially if you have a stable environment. Then with moderate, you know, especially web servers, we usually run reasonably few but solid services on it. But on desktops, you write a multitude of diverse software that you may or may not use, and you kind of lose track. So it's much more likely to break something in my view, in a desktop environment than it is in a pure server environment, which Linux should be in the first place. I, by default, always run it as a console variant. So we have sudo apt-upgrade. Yeah, so that's what you get here, and it says, hang on, there's quite a bit of stuff we need to upgrade. Those are all the packages. I would ask you to download 166 megabytes and so on. We're not doing this right now because it's just a tedious exercise, but it's all the stuff it would actually update for you. Cool. Everything solved? Any problems with the apt and apt-get?
Might break stuff.
Yeah, might break. Rarely, but it might break. You're right. There's issues there. Yep. Anything else? But from your experience, did anyone install Go using apt?
Oh yeah, the repositories might not have the most up-to-date.
Exactly. The next thing after installing Go using apt is uninstalling Go using apt. So that's you know, and the command is apt remove. By the way, the command sudo apt install, and then you say go lang, I think, right? So go lang go or something like this. And the other one is sudo apt remove. And the point is the repositories are usually quite out of date because it requires the distributor for, what was it now, 82,000 packages to ensure that you have pre-compiled packages that fit your Linux distribution and have them current. Yeah, and this is kind of you know, their business model builds on open source, so they put the emphasis into consulting mostly, and they will most likely focus on packages that are relevant for their business, for this consulting role, or on free voluntary contributors that actually help doing that, which, you know, every one of you is invited to do, but it's tedious and realistically not happening too often. So most likely you need to wait for a next distribution to get decent set of, you know, reasonably fresh updates. I'm not sure, what was the version of Golang that is hosted in Ubuntu 18.4? That anyone?
1.10 maybe.
Oh, it's not too bad though.
Maybe I remember wrong.
Okay, that's not too bad. It's only one behind, so I was expecting worse. That said, it only came out in April, right? So it's quite recent.
Or maybe it's 1.7 maybe.
Right. Okay, then it's a bit flaky already. So that's the reality that we're facing. And for most of the packages that we are installing, we kind of need to do some manual stuff because we want to work on the cutting edge work.
But you can actually add different PPAs
yeah.
that are more bleeding edge for
That's right.
your specific.
So what's PPAs? Since you're extending the
source.
yeah. So yeah. So that comment is very valuable. So if we, where is it? Apt
Sources.
cat sources. That one. Cool. Of course, you can change your repository you're feeding from, right? So by default, it use the canonical ones. Here, for example, is the NZ archive of Ubuntu. Probably because I selected New Zealand as the standard country. But of course, you can add your own ones. If you're hosting, you can host your own software repository, including all those packages, and point to your URL. Perfectly fine. There's a lot of third-party providers, and they may have different versions of those software, so you can get more bleeding-edge stuff. Absolutely right. But in a stock installation, that's the kind of thing you get. And what would happen, you just need to modify this file. This file was sitting in etc apt sources.list. Remember, etc is all that global stuff, right? So system-wide configuration files that are kind of relevant for all users. Cool. So usually out of date is what I wanted to end up with. That is fairly good. Also, before I continue, note in some distributions you will find that apt is not working. So then you need to use apt-get as a variant, right? That's the older version. The same command principle, slightly. The relationship is roughly between apt and apt-get is like the relationship between top and htop. That apt actually shows your progress, apt-get doesn't. It just does the install, but it doesn't give you a big picture. It could take 2 days, the installation, but in apt you actually see a progress bar. that gives you a bit more context. So in case you're wondering that you have some web server somewhere hosted and it doesn't have apt, try apt-get and you have the same effect. Cool. Sweet. So far so okay. Who's still awake? 1. That's average. 1.5. Oh no, that's just because he's watching a movie. Okay. So right. Still, it's a bit dry. I admit it, but we need to get that.
How do you know that when you install a package that it's secure? I think I read somewhere a few months ago that Linux removed 3 packages because they had some.
You don't.
You don't. You're absolutely right. So because why don't? Why?
First off, since it's a community-driven effort, there might actually be somebody who has injected another package with a known security flaw. But also because a lot of packages are actually behind, there might be known vulnerabilities to packages that you install, and there might be new introduced ones. And of course, if you have external package layers as well, you know you can trust them.
So yeah, you don't. Absolutely not. So you need to, use read security logs and so on, and be aware of. Basically follow all CVEs and see if there's a latest vulnerability that applies to a package of your choice with your version. So it's basically the only you can do. That's the tedious task of the sysadmin, I believe. To keep an eye on this, but it's another motivation for keeping as few services on your system running as possible, right? So because then you minimize this impact. People using DOS desktop machines often don't care as much about it, but it's for servers, of course, very relevant. But realistically, while there are a lot of bugs, the exploitation rate is usually considerably lower compared to Windows systems. So it's next to safe by default. I'm saying that with care, of course. There are viruses, but realistically, you will not be as much exposed unless, of course, you run a server. You need to be.
You have the OpenSUSE.
Yes, bleed. Yes, that was what was it called? Heartbleed, right?
Heartbleed.
That's right. That's something. But in this case, it's really tough one because you may not actually be able to upgrade it at all. The only thing may be to actually reinstall your entire system, right? But yeah, of course, those are pertinent. Risk issues. On the other hand, you can just, since it affects pretty much everyone, the probability that you will be directly affected, meaning exploiters, could be considerably low. But you shouldn't, of course, play with statistics on those ones. Okay, cool.
And of course, you can safeguard for Heartbleed. You could actually safeguard using proxies.
Yeah.
In between.
Yes. So you could set up a proxy machine in between to mediate direct access to the web server, which you would do anyway, most likely for not only security but also performance reasons, right? So load balancing and so on. But that goes beyond. I think we should stick to what we need for this course. Else we may be coming back to load balancing eventually later, but that's more like an optimization feature. Okay, there's of course software for desktop that we can run, desktop tools, and here's the overview of all important commands: update, upgrade, dist upgrade, the scary one. Install, apt remove, and apt purge. I want to mention that as well. The reason is sometimes when you install software, it's not really that the software doesn't work properly, but it's maybe that it's somewhat misconfigured. If you use third-party tools that change the configuration files, it may just be the configuration files that are messed up if you like. And if you run apt remove package name apt install afterwards, you will have the same problem again because the configuration files are retained. So in this case, try apt purge package name. It deletes the package from the system, but also all the configuration files relevant for it. Yep.
You should also, in a lot of cases, run auto remove to remove additional packages that the package you removed.
Yeah. That's right. That should be all here as well. That's right. Apt auto remove is another one that is worthwhile to clean up your system a bit. Cool. So nearly done. Are we done with Linux installations? No. So there's another one. So we have the beautiful solution of actually having a software package and dependencies. But the guys at Canonical figured something out. Actually, I talked to one of them last year, and it was beginning of last year, and he was mentioning, okay, it's super tedious. One of the main problems is there's not only, of course, dependency problems that relate to managing dependencies that belong to a different software package. But in the meantime, given the plethora of different installations on systems, there's oftentimes dependencies on very specific versions of packages. So for example, there's quite a bit of server software that relies on different versions of Node.js on the server, right? Same for Python. Are you running Python 2, Python 3, right? Is it perhaps tied down to a particular version? And they had trouble dealing with this, because even if you resolve the dependencies, then you have 5 different installations of Python on your system, right? And good luck keeping track of what relates to what. And you need to accommodate the fact that they may actually conflict, right? So not only may they not persist along each other, shouldn't they exist along each other, may just confuse you, but they actually may conflict in themselves. So that was their problem. And I thought, okay, they need to deal with this in a different way. So apt is pretty good. So you basically download all the dependencies, put them right spot, and download the binaries and run them. And they wanted to, thought, okay, here, by the way, just to motivate that a bit, here's the dependency tree, a subset of the dependency of the Apache web server, which is kind of a standard web server on the web. This is just really a small snapshot of all the dependencies that exist. And it's down to versions that are supported or not supported. So the complexity of this tool should not be underestimated. It's actually kind of magic that Linux works the way it works. So, and the idea to the solution is, what is the idea they had? Does anyone know?
The hash?
Sorry?
Idea of the hash?
No, what was their solution to that problem? So I mentioned that we have various versions of the same problem, software, or dependency installed on the system. How do we deal with this in an alternative way? Any idea?
You do have the possibility. There is at least one way I know of that you can do it, and that is allowing to have multiple versions side by side, where the latest version is directly accessible to the user, but other systems might use older versions, but it's hidden from you as a user.
Yes, that is of course. But what I'm thinking about here is how can we automatically guarantee consistency? In this case, you're meaning fiddling around with configuration files and hoping that it works out, or eventually it works out. That's not a realistic assessment, because if you think the standard user will not do it, they just see, oh, error, done, right? I don't want to deal with this, and most likely they don't want to read source or configuration files. So the idea was that, well, we do every time we have that issue, we deal with it in a different way, and usually it leads to more inefficiency. Let's package the entire application, including its dependencies, so the whole bunch. So if you have 5 different tools that rely on Pythons, you will have 5 times Python, but not installed in the system, but retained in some sort of container, which is a so-called snap package, a self-contained snap package. And the equivalent from Red Hat, of course, they have the same problem. They call it Flatpak. So if you come across those two ones, they're specific to the particular vendors. But Snap is the one that, of course, would need to be used in an Ubuntu case. And it's very similar to actually what you guys know from Play Store, for example, that you also have self-contained packages. Of course, a lot of redundancy, because you may just reinstall stuff you already have installed like 5 times. But at least it still works when you uninstall the other 4 packages, right? And the same thing is here. The argument was, well, this space is free, effectively, from a server-side perspective. From that, yes. Well, we're not talking data; we're talking programs, right? So a gigabyte of additional software doesn't bother us. Of course, 1 terabyte would bite us a bit, right? So that's the kind of dimension we're talking, because realistically, that software is downloaded via the wire anyway, and you're not downloading terabytes. So the intuition was there, it doesn't cost too much to just have multiple versions installed anyway. Plus, there's a security benefit, we isolate, right? So of course, if one of those packages that we have installed has some security flaws, as mentioned before, it doesn't necessarily affect the entire system, but it's reduced to this very instance that we're dealing with. That was the idea. And the tool for that one is called Snap. You don't need to install it anymore in 1804, but since it affects the entire system, it requires sudo rights, so super user rights. You need to run super user do, and then this is the help that you basically see. And what you can do is, I just run the snap list, see what I don't know, what did I do here? That's the installed ones. So installed various snaps before, which is of course the core snap that is related to the daemon, and then some demo snaps that are available. So you can use, say, sudo snap find, and then the tool of choice. I just type Apache, for example. And then you find different versions. Again, it's community driven. So it's the different contributors with varying levels of reputation and risk and so on that actually provide the packages. But you can directly then install a ready-made version of Apache with one click, one button press basically, and also uninstall it the very same way. So it's really quite straightforward now. But it's completely self-contained, meaning the download will be considerably larger compared to what was the case before. But more than in the case of apt and its centralized repository, in this case, you kind of really need to watch whom you're downloading from, because it's much more community-driven. And I think 2 months ago I read something, someone provided a meaningful application and included some Bitcoin miner in there. So suddenly your CPU use would go up considerably once you installed that snap. But of course has been removed in the meantime from the repository, but it's something to be aware of. But okay, so that's basically the third way you can deal with this. So let's sudo snap install
Certbot. Is it available?
Managed by Tomcat with SSL. Apache Tomcat with SSL activated and managed by Certbot. It's the second on top. That's a line break here. But for example, a good one to, of course, look for, and this may actually be more updated. Let's check Golang. Sudo snap. So, it's a bit out there. So which versions do we actually find? Golang based, those are applications. So many people just put the applications there, not necessarily the language itself. So if we just put Go, we get a bit more. Oops, we get a bit too much more. Anywho, so we may find a... Anyway, so this is a bit more open, so more people contribute, but they also contribute their own not so much meaningful applications. So it's a bit of a mixed field, be aware of it. But if you find it in Snap, it's a lot easier to install and manage in general. So that's the third way of dealing with packages. So that's the key idea. So, and then here, of course, it relies on a centralized server, so you need to have internet connectivity, and updates are run using snap refresh, sudo snap refresh, and sudo snap remove for removing packages. So that's basically the overview there. So if you see something like apt or snap coming up on you, those are tools of choice that you want to use, and that's the reason why we have them, right? So originally install individual packages. No, there's 4 different ways. Originally compile from source, install manually. Second version was downloading deb packages and manually installing using a command dpackage, which doesn't matter right now. Third version was using apt, actually having centralized repositories that keeps track of all those deb packages. Fourth version, snap. So, okay, that's quite a bit of installation going on. And I know you don't want to become sysadmins, but kind of get it if you do it to cloud technologies. You're kind of getting that edge, that corner. All right, since you're all falling nearly over, I'll probably give you a bit of break. How much time do you need to recover? I know the rule. If I give you too much time, you will never come back.
10 minutes.
10 minutes, okay. 17 then, 9:17. Okay, cool. And then we talk a bit about rest. Something more exciting, hopefully. Let's see.